Now we want to talk about a third kind of energy resource, and this is going to be nuclear fission. So let's first talk about the atom. An atom consisted of a nucleus, and then the electrons were in orbit around it. Now there are some kinds of nucleuses that are unstable. So they may have too many protons in their nucleus, or they could have too many neutrons in their nucleus. So one way or another, that nucleus is going to be unstable. It's got too much energy. And so what we could do is if we hit that nucleus with a neutron, it will cause that large nucleus to break apart into two smaller nuclei, that are more stable than the original nucleus. So we start with a large nucleus, we hit it with a neutron, it's going to break apart into two smaller nucleuses, and then it's also going to release some more neutrons. So one neutron went in, and actually 3 neutrons comes out of this thing. And then it also gives off energy. Now that energy was originally being used to hold that nucleus together. But after it breaks apart, some of that energy is going to be released, and we're going to call this nuclear fission. So where do we get these radioactive nuclei? So normally we're going to get it from uranium. So where is uranium found? Uranium exists inside the Earth. So we mentioned earlier that the inside of the Earth is hot because of radioactive materials decaying and releasing heat. So one of the materials that's inside the Earth is going to be uranium. And then what can happen is magma coming up to the surface can carry some of these radioactive elements with it, and then they can be incorporated into igneous rocks such as granite. Okay, then what can happen is hot water. So if you recall, we talked about hydrothermal metamorphism. So the use of hot water percolating through rocks. So hot water circulating through that granite can dissolve the uranium and precipitate it in veins of the mineral pitchblende. And so that is the chemical formula for pitchblende, and then that's what it actually looks like. Okay, so now we've got the uranium has been concentrated into these veins, and now the next thing that can happen is the weathering of these veins at the surface can produce concentrations of uranium in sedimentary rocks. So we said the way that you make a sedimentary rock is you weather existing rocks, and then those sediments get glued back together. So this is a way of concentrating the uranium in a sedimentary rock, and then we can mine that to get our uranium. So then the next question is, what do we do with the uranium once we've got it? So we can make a nuclear fission power plant. And so I'd like for you to watch this little video here on how a nuclear power plant works. Okay, so the idea is going to be that we're going to take the uranium, we're going to turn it into these little concentrated pellets. We take the pellets, we put them into a tube. Okay, then we take the tube, we put it into water, and then as this stuff undergoes radioactive decay, it's going to release heat. The heat is going to heat up the water. The water in turn is going to turn into steam. The steam is going to turn a turbine, and then the turbine is going to make electricity. So I'd like you to watch that video and to learn more in more detail how does the process work. So how many nuclear power plants does the United States have? So currently we have about 104 power plants, and they generate about 11% of the energy that the United States uses. And then that shows where they're located at, and you will notice that some of them are kind of located in bad areas. So the ones on the western coast of California, you can see, are very close to the San Andreas Fault, where they have earthquakes. And so that could be very dangerous if the power plant was damaged that way. Then you'll also notice that some of these power plants are located next to the Gulf of Mexico, which you get hurricanes. So again, hurricanes could damage the nuclear power plant. Okay, so how much hydrocarbons, coal, and uranium remain? How much do we have to work with? So you will notice that the units for the amount of energy are in quads. And so we've already defined what a quad is, and it is a large amount of energy. So you can go back and look at that previous video to find out just how much energy is in one quad, much less hundreds of thousands of quads. So you will notice that the majority of energy that is still inside the Earth is going to be in the form of uranium oxide. So materials that we could dig up and then use in nuclear fission reactors. And then you'll also notice that there is a tremendous amount of coal inside the Earth, and we mentioned that we could use the coal, if we had to make gasoline with. And then you can see that there is also a lot of oil that is trapped inside a rock, so that's your unconventional hydrocarbons. And then you've got crude oil and natural gas, which are your conventional hydrocarbons. So that gives you an idea for just how much energy is still left inside the Earth. Okay, in our next segment, we're going to talk about other sources of energy.